All right, and today we're going to learn about let's say this together, okay? Repeat it. All right, and let's go ahead and look at our objectives. So today let's please say this together. Are you ready? Today I will learn various geography terms so I can understand what my teacher and other people are talking about when they use these words, right? So if we say plains or if we say plateau or something like that, and then now you'll know what they mean. So for example, mountain, glacier, iceberg, precipitation, some words we're going to learn today. And next, I will know I have it when I can tell my friends and family what each of these terms mean. Now that seems pretty straightforward, but it really is that simple, okay? And I know there's a lot here, but you will know that you understand this material when you know what each term means and you can explain what it is. And ideally, even best case, if you can explain why it is the way it is, right? So for example, one of my favorite ones is why a desert exists. And it's not all deserts, but some deserts exist because you have a mountain and there's lots of rain that falls on this side of the mountain because the mountains are tall. And so it kind of like the clouds hit the mountain and it falls down as rain. Then on the other side, there's no more rain because it just fell on this side of the mountain. So because there's no rain, it's dry and it's a desert. All right, so there are some terms that we need to know for today. The first one is erosion. Erosion is the term we use to talk about how water or wind can move earth, okay, like dirt or rocks, okay? When water falls from the sky as rain, or it could be an ocean or a river or a lake or something, that water runs up against the rocks or the ground or the dirt, it actually pulls it away. And in some cases, parts of that, like salts and things, will actually dissolve in the water, okay? And then it gets moved by the water to a different place. That's a very big concept. The second one is with the wind. Okay, so as wind blows, it can blow the dirt away, the little particles of dirt into the air, and slowly over a long time, thousands of years, it can send more and more dirt away. Or it could knock things down. It could knock down rocks off the top of a mountain or something like that. Same thing with water. And these are how the world has changed its shape to look like how it does today. So we're gonna use basically the idea of erosion to talk about how Earth has changed and then how we get to the geographical terms. Now, there's a lot of terms today, so it's a really good idea if you write them down or take a note on your computer or something. So every new term that's brought up, make sure you write it down. You have to write it down, okay? Yeah, and there is a document on Schoology. It would be great if you would download that, and then you can type it in, or if you print it off, then you can write it out, or you can use it as a way to keep track of where we are in the video. They're pretty much in order, and so if you fill that in, it'll be helpful on your assignment for today. Okay, so we have another guest teacher today, and we're going to learn about the physical features. This is lesson 3 of chapter 2 in your book, and it's the physical features of the world. So different things like plateau, plain, isthmus, different words that we use to describe geography. Okay, and we're going to use these words throughout the entire year, so this is very important.
If you look at a mountain, they are formed due to the movements of tectonic plates. They are formed by slow but gigantic movement of the Earth's crust. This is called plate convergence. When two continental plates collide, it pushes the rocks upward, and that forms a mountain range. A good example is the Himalayan mountain range. They were formed as a result of the collision between the Indian plate and the Eurasian plate, which began 50 million years ago, and it still continues today. So this is how the mountains are formed. You will also find many mountains near coastal areas. These are formed when heavy oceanic plate collides with a lighter continental plate. The oceanic plate sinks beneath the lighter continental plate, which results in coastal mountain ranges like the Andes, Western Ghats, the Aleutians, the Japanese and the Southern Alps. Now the next question is why there is a snow on top of the mountains. These are called snow-capped mountains. The top of the mountain is actually its coldest spot. Now you might have another question. Since the top of a mountain is closer to the sun, it should be warm. And doesn't the heat rise? So why is there snow? Now if you climb a mountain to a higher altitude, the atmosphere gets thinner and thinner. This is because air pressure decreases with altitude. When warm air rises, it expands and cools as the altitude increases. Due to that, the warm air cannot absorb and retain the heat the way it does at the bottom of the mountain. Although mountain tops are closer to the sun, they are also farther away from the thermal heat of the Earth's core that keeps the ground warm. So the top of the mountain can be much colder than the bottom. Cooler temperatures at the top of a mountain also mean that there is less evaporation taking place. This leads to greater amounts of moisture in the air. More moisture means more rain. But when you're at the top of a mountain, instead of rain, it snows. And that's how you get a snow-capped mountain. By the way, not all mountains have snow caps, and not all mountains that get snow have snow caps throughout the year. It all depends upon the location and how tall they are. Now coming to glaciers. How are glaciers formed? It is very easy to understand. Glaciers begin to form when snow remains in the same area for a very long time. I'm talking about an entire year. This way, each year a new layer of snow is formed on the previous layers. This compression forces the snow to recrystallize, meaning those tiny snowflakes becomes tightly packed together. As time passes, the density of these accumulated snow increases. If you go underneath a glacier, you will notice that the bottom layer of a glacier slowly melts. Most of the water recrystallizes and forms like a rock. Here is a map that shows where in the world you will find glaciers. Mostly glaciers occur in high latitude and high altitude regions. Glaciers are usually formed on steep slopes. I mean, this is the place of their accumulation. And if you look at the movement of glaciers, the bottom layer of the glacier, which is also called the glacier bed, it starts to melt. And that reduces the friction between the glacier and the bedrock, making the entire glacier slowly move. Now, when a big piece of ice breaks from a glacier and reaches open sea or ocean water, that is known as iceberg. By the way, glacier is a freshwater source. Please keep that in mind. So iceberg is a large piece of freshwater ice floating in the open water. If you ever see an iceberg, only the tip of the iceberg is visible above water, while nearly 90% of it is underwater. After all, it's a heavy piece of glacier. Glaciers are commonly found in high latitude regions like Antarctica and Arctic region, which consist of places like Alaska, which is in the United States, Finland, Greenland, Iceland, northern Canada, Norway, Russia and Sweden. The next one is Jord. The F word is silent when you pronounce it. These are a long, narrow, deep inlet of the sea between high cliffs. How are they formed? They are created by glaciers. I just told you how glaciers are formed, right? Glaciers move downslope very slowly over time and can greatly alter the landscape once they have moved through an area. When a glacier starts to move, it starts to carve the valley and forms a land depression. This carving of the steep valley is known as Jord. A Jord is often deeper than the open sea. It can be thousands of meters deep. As a result, water fills up and forms a deep inlet of the sea. Jords are found mainly in Norway, Chile, New Zealand, Canada, Greenland, and the state of Alaska in US. Jords are home to several types of fish, plankton, and coral reefs. Now coming to a volcano. Volcanoes are found when magma comes out within the Earth's upper mantle. Now how does magma comes out of the Earth's crust? It can happen in two ways. When two tectonic plates collide or when two tectonic plate moves apart. The mantle is the layer that has magma. When the oceanic plate comes in contact with the magma, it creates huge pressure that causes the magma to push through holes or cracks of the continental crust, causing a volcanic eruption. A good example is the Ring of Fire in the Pacific Ocean. The Ring of Fire is a ring of volcanoes around the Pacific Ocean that result from collision of oceanic plates with lighter continental plates. Now coming to the second scenario, when two tectonic plates move apart from each other. It is called a divergent boundary. It can occur between two oceanic plates or two continental plates. When there is a divergent plate boundary in the ocean, in other words, when two oceanic plates are moving away from each other, molten basaltic magma from mantle comes up and spreads on the ocean surface. It is also called a mid-oceanic ridge. When magma comes out, it forms underwater volcano or submarine volcano. The most famous example is the mid-oceanic ridge of Atlantic Ocean, which divides the Eurasian plate and the North American plate. Divergence happens in two continental plates too. That's how new ocean forms. Volcanoes are not formed, oceans are formed. The exact reasons as to why it happens and where it happens and how it happens are still being studied. The best example on Earth today is the narrow Red Sea, where the Arabian plate has pulled away from the African plate. It is a perfect example of what happened when two continental plates are moving apart from each other. The next one is Tundra region. Now these are places with low temperature and you will find them in the North Pole, that is in the Earth's northern hemisphere, and also places with high altitude. The land area of the North America, Europe and Asia together are often referred to as the Tundra region. In this picture you can see this region being located just at the bottom of snow-capped mountains or glaciers. This is called the Alpine Tundra region. The word alpine means mountain. In this ecosystem, you will rarely find trees. Mostly you will find small shrubs, flowers, sedges, grasses, mosses and lichens. The wildlife in this region consists of musk ox, yaks, mountain goats, snowy owls, Arctic foxes, polar bear, etc. The temperature of this region is mostly dry, cold temperatures. The next one is geyser. Now geysers are like hot spring, where warm surface water comes out of the ground. So how does the water become so warm? When surface water comes in contact with rocks that are heated by magma. This is called geothermally heated water. It then rises towards the surface by the process of convection. And this warm water comes out of the surface through porous and fractured rocks. You will find many geysers around the world located near rivers, because that is where the groundwater is adequate. If you want to trace the source of these geysers, you will have to go deep into the Earth's crust, because the water in geyser is heated by magma, and that lies at least 5 km beneath the surface of the Earth. At some places, it is not because of the magma, but it is because of the solidification of magma which turns into igneous rock, and the heat of that rock makes the water boil. One more point you will have to remember is that many geysers are located at the edges of tectonic plates. The next one is desert. When we think of desert, this kind of a sandy picture comes to our mind, right? But then that's not the only desert. There are basically 4 types of deserts. The first one is hot and dry desert, which exist in the subtropical region. They are along the Tropic of Cancer and Tropic of Capricorn. At subtropical region, it is due to pressure differences and circulation patterns of air masses hinders the formation of clouds. That is why there is very little rainfall on the land, which eventually causes subtropical deserts. Basically, a subtropical region is a high pressure zone. If you want to know why it is, then please watch this video. In this I have explained why subtropical region has high pressure. The link to this video will be there in the description. The second type of desert is rain shadow desert. I want you to watch a video where I have explained different types of rainfall. In that I have explained about orographic rainfall. So there are 2 sides of a mountain. One is the windward side and the other is a leeward side. By looking at the name, you can easily figure out that windward means the side of the mountain which faces a lot of wind. As a result, rainfall occurs. And leeward side is the opposite side, where it is dry and there is no wind. That means there is very little or no rainfall at all on the leeward side of a mountain. So these semi-arid and cold winter deserts are found on the leeward side of a mountain, which are also known as rain shadow deserts. When moisture hits a mountain range, it is forced to rise. As a result, the air cools and forms cloud. Because of that, it rains on the windward side of the mountain. After that, when the air moves over the mountain top and begins to descend on the other side, there is very little moisture left. That descending air warms up, making it difficult to form clouds. Hence, there is no rain on the leeward side of the mountain. So the region on the leeward side of a mountain also becomes a desert. Some examples of rain shadow deserts are Mongolia's Gobi Desert, the eastern part of Western Ghats. If you look at the state of Karnataka, you will find many mini deserts which are located on the eastern side of Western Ghats. Another example is the Sahara Desert, where the northern part of the African continent is covered with Atlas Mountains that blocks the wind from the Atlantic Ocean and the Mediterranean Sea. And that's what makes the Sahara Desert a rain shadow desert. The third type of desert is coastal deserts. When cold ocean currents blow towards the shore, these winds are cold because they are in contact with cold water and they produce a layer of fog, which is a thick cloud of tiny water droplets that are too small to fall as rain. Now this heavy fog moves onto the land, but the sun's heat makes them disappear during the day. Since there is no rain, the coastal region turns into a desert. Some examples of coastal desert includes the Namib Desert in southwestern Africa and Atacama Desert in Chile. The fourth type of desert is cold and polar desert. Examples of polar deserts are Antarctica, Alaska, Canada, Greenland, Iceland, Norway, Sweden, Finland, Russia. In India, we have Ladakh, which is a cold desert. Even Mongolia's Gobi Desert is a cold desert, but it is also a rain shadow desert. Patagonian Desert in Argentina is also a cold desert. So the important point that you have to remember is that all these different types of deserts have one thing in common. They lack humidity and moisture. When there is less of humidity or moisture, that's when there is a shortage of rain. And deserts are areas that receive very little precipitation. Now that you know what is a desert, in a desert you will also find oases. Oases can be naturally formed or man-made. Basically, in a desert, if you find a small region where there is water on the surface, it is called oasis. In a desert, you will notice that the winds carry large amount of sand. In many areas of desert, this kind of natural action creates land depression. Water from the ground is basically obtained if you start digging the earth's surface. When it is manually done, it is called a man-made oasis. And when it occurs naturally, due to wind blowing, erosion or any kind of landslide which creates fault, and that allows the water from the ground to reach the surface. If you look at this picture, you will see that the groundwater rises due to change in land elevation. If the groundwater is closer to the surface, then oases are easier to form due to natural reasons like strong wind blowing, erosion, landslide, etc. Because all it requires is to breach the upper thin layer of the ground that covers the layer that has water. Once it's done, the water comes out on the surface, and that is how an oasis is formed.
All right, everybody. So we need to remember this concept because it's very important about deserts. So can someone please explain? I want you to raise your hand, and then we'll actually have you explain how a desert is formed involving wind, mountains, and rain. How is a desert formed? Someone raise their hand for that?
The next one is plateau. A plateau is a flat elevated piece of land that is higher to the surrounding land area. There are two kinds of plateau, dissected plateaus and volcanic plateaus. Dissected plateaus looks like this. These are formed due to upward movement in the Earth's crust. One side of this plateau will have a slope. Basically, when two continental plates collide, that is how mountains are formed, right? Even plateaus are like mountains, except it has a flat top. So even dissected plateau is formed due to slow collision of tectonic plates. A good example is the Colorado Plateau in US, then Tibetan Plateau, then Mexican Plateau in Mexico, and Patagonia Plateau in Argentina.
All right, now we want to do a different activity. So you'll need a piece of paper and a pencil, pen, something to write with. And number one, what I want everyone to do is draw a picture of a mountain, okay? Draw a picture of a mountain, first of all. All right, go ahead and hold it up to the camera, show everybody. A picture of a mountain. We can pause the video here. All right, next, we want to draw a picture of a plateau. And you can use the same piece of paper. A picture of a plateau. Let's draw that and show the camera. We can pause here. So how are these similar and how are they different? Let's talk about that. Maybe we can type in the chat, okay? How is a plateau different from a mountain? And have you ever seen a plateau?
Even in the oceans, you will find plateaus. Ocean plateaus are of two types. One is made of continental crust and the other is made up of igneous rock due to solidification of lava. The next one is Butte. It is an isolated hill with sharp vertical sides and flat tops. Buttes are smaller in size compared to a plateau. If you see, buttes are also plateaus, but due to continuous erosion by water, rain and wind, they have turned into tall, flat-topped landform.
Okay, so what we're talking about here is a couple things. First of all, It might shock you, but whenever you have the ocean, right, when you look out at the ocean, it just looks flat. But actually, it's flat just because the water fills up to the same level pretty much all over the entire world. That's why we call it sea level, because it's the same level all around the world. Now you do have the moon that kind of pulls at that, which is why you have waves. But anyway, but under the water is ground, right? There's actually earth under there. It continues to go down, and it doesn't just go down, it will go up and down, and there will be even like mountains under the ocean, or there will be big valleys, which we call trenches, under the ocean. And there, as he says, there can also be, you know, plateaus under the ocean, which is pretty cool. So we don't really need to know much about which mountains are famous or anything like that for that, but we do need to just understand the concept that under the water, there's also different kinds of physical features, okay? And the second one is that there's a butte, okay? So B-U-T-T-E. The whole point about this is that water, when it falls from the sky as rain, it will run and it will actually dissolve the rocks and the dirt and whatnot, and will take away part of the rock, which is why something, like if you look at the Grand Canyon, it looks flat, but there's a big gap in the middle because all of that part got run away by water, and the only part that's left is still flat. So a long time ago, all of the area of the Grand Canyon would have been flat, and just slowly, you know, it got deeper and deeper because the ground or the dirt or whatever you want to call it, the rock, kind of melted away. It dissolved into the water and flowed down the Colorado River.